All right, now that you are experts, so to speak, in rational exponents, we now want to do the same types of calculations, but the difference will be negative rational exponents. So looking at our student goals again, we want to still be able to evaluate anything in the form b to the n, where n is bigger than 0 and n is a rational number. So that would be any fraction, but because we already know that our goal is to use negative results, that probably means that our fraction is going to have a negative value of some sort. Simplify expressions or solve equations using these properties of exponents again. Solve equations in the form x to the n, where n is a negative, that's what we talked about, and then applying these properties, same properties, to real-world problems. So getting started, take a look the rational root, negative rational root exponents. The real only difference, if you look at this real carefully, from our last section's discussion, is now instead of just m over n, we have a negative floating around. So instead of 2 things to do, think of it as 3. Now the question is, which ones do I do in order, or what order do I do them in? Does it matter what order? Efficiency versus not. Does it matter whether I'm using a calculator or not? So remember, innermost parenthesis is always done first. So in this top one, I'm saying go ahead and do the reciprocal first, then do the power, and then do the root. In the second one, we're saying do the root first, then do the power, then do the reciprocal. In the last one, we're saying reciprocal, then root, and power. Now, some people say, well, shouldn't you power first? I'm not sure powering is going to be your number one choice, because remember, in most cases, powering first is going to just make it bigger. And when it's bigger, especially without a calculator, I'm not sure bigger is better. So, looking at here, we say, especially with no calculator, it would be good to take the root first, then take the power, and then, last but not least, take the reciprocal. So going downward here. If that doesn't work for your brain, then I suggest the only other choice be do reciprocal, then power, and then root. So working up the list. Now, we'll show you in our work today, or examples, when it's good to do reciprocal versus root. So think of it, root, power, reciprocal, RPR. Now, which order do you do the R's in? That's what we're going to have to talk about. Root, power, reciprocal. So let's try a couple examples and see when is it good. All right, focusing on one at a time here. If we have 125 to the negative 1/3, really you have to ask yourself, how many things are happening? Some people would say 2, some people would say 3. I personally would say 2, because we knew that 1 over anything really was just taking a root. Now add the negative to it. So in this case, I would do the root first, then I would do the reciprocal. There's really only 2 things to do. Because if you want to say, well, I got to do a power and I got to take it to the first power, taking anything to the first power doesn't really change your value. So, thinking-wise, if you're going to break it down and rewrite it, especially without a calculator, your brain has to be doing 125 to the 1/3 power first. So it does the root. What is that one number that multiplies by itself 3 times to give me 125? And most people will say, there's 5. Obviously, that -1, that negative sign and that 1, obviously multiplied here together with the 1/3 would give us -1/3. So we now need to do that -1 exponent on a 5. But remember, x to the -1 is nothing more than the reciprocal of your number. So 5 is screaming out, flip me, if you like that, or 5's reciprocal. And 5's reciprocal is the fraction 1/5. Notice, we did not have a negative final answer. A negative exponent does not mean I am a negative result. So, another example using those properties. This one does have all three parts. So we have a fraction to begin with, we have a negative sign, we have a power of 2, and we have a root of 5. So how are we going to handle this? Again, if I'm going to do this without a calculator, I like the idea of root first. Make everything smaller. And we have a fraction, you're going to say, well, I got to make that even smaller. Think of this fraction as two parts, two whole numbers might be a better way. And so right now we are going to take the 1/5 root of both of those. After that, you could square it, and after that, you could think of to the negative first. And if you multiply these three together, exponents, they always have to equal the one you started with. And they do. So look at it. We said RPR. We did the root, we did the power, we did the reciprocal. So let's go. What is the 5th root of just the number 32? What number multiplies by itself 5 times to give you 32? Most of you would tell me 2. Do the same thing with the 243. What is that one number that multiplies by itself 5 times to give you 243? If you don't know, you just did 2 to get to 32. Start with a 3. 3 times 3 is 9. Another 3 times 3 would be another 9. And you know 9 times 9 is 81. But we need one more 3. And that one you can almost do in your head. 81 times 3, look what it is, 243. So fairly quickly, you can get that the 5th root of 32 243rds is 2/3. Now you got to square it. You can square both of those fairly quickly. And then last but not least, reciprocal. Flip me. And your final answer had better be 9/4. I would stay away from decimals there. Don't go 2.25. There's no reason. You're going to recognize it from the 9/4 in your work. That is simplifying. Get it down to where you have nothing left to do with your numbers. Make sure your fraction, if it still is a fraction, is in lowest terms. On these, notice there's a multiplication going on. But in the multiplication, we don't want you to think of it like multiplication. We want you to think of it as, here's the root, negative rational exponent, as is here. And then when you finish that, go ahead and do the multiplication. So simplify that root part first. So here we go. What is the 7th root of 128? Some of them are easy to do in your head. Some of them are not. If you don't know, you just start and pick a number. In this case, we're just going to start with 2, because 7 times, that's a lot. So here we go. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 more, and that's our 7th 2, is 128. So we did the 7th root of 128, and we got an answer of 2. We are now going to take the power of that, which is the 5, and going backwards now, 2 times 2 times 2, 5 times, would give us 32. And then that negative exponent is screaming out, flip me, reciprocal. And so we have a final answer of 1/32. Looks good. Next one. But remember, I say next one, you're not done with that one, because that was just the circled part. Go back now, 8 times that 1/32, finish the problem. 8/1, look at what we've got. You should recognize this as some canceling. You can do top times top, bottom times bottom, but if you notice 8 and 32 have a common factor of 8. 8 goes into 8 once, 8 goes into 32 4 times. We will end up with the fraction 1/4 for our final answer to this whole original problem. The 128 to the negative 5/7 was our 1/32. But taking that and timesing it by the 8 simplifies it to 1/4. All right, other side. This one's a little smaller, maybe down in your head, but ready? 16 to the 4th root. What one number multiplies by itself 4 times to give you 16? Most of you know that's 2. You would cube that as your next step. 8. Reciprocal is all that's left, so you're getting 1/8. Again, don't stop, because all you have done is the rational root. Go back 4 times that 1/8. 4/1, do your canceling. 4 goes into 4 once, 4 goes into 8 twice. Final answer looks like we have 1/2. Again, with no calculator, that's what we want you to start working on. Because if you just punch the buttons on the calculator, you are not doing anything to force your brain to think of what is the calculator doing to go through that process. All right. Another equation, this time we got our negative rational exponent. So problem says, what am I going to become? Well, most people will say, well, wait a minute. I need y by itself. Anytime you see the direction solve, you're saying get y by itself. We talked about undoing a power of 3 with a root of 3, undoing a root of 5 with a power of 5. So we could get rid of the 3/5 very easily with 5/3. But don't forget that negative sign's not going to go away unless we have another negative. So if we take both sides and take it to the negative 5/3 power, and it truly is, whatever you do to the left, you must do to the right. It's one of the major properties of algebra, to keep this thing balanced. The left-hand side is totally gone when we look at our canceling, and which leaves a y to the first, which is y. Now here's the first time it would make sense when we said RPR, root, power, reciprocal. I have a fraction here. If it's easier for you to calculate, it makes sense to take this fraction and flip it first. So this time I'm going to do reciprocal first. So the reciprocal of 1/8 is 8. And now you've got to say to yourself, well, that means I still have the 5 divided by 3, or 5/3 remaining. True statement. So let's do, again, in the same order. Once we did the r, we don't want a power because that would be 8 to the 5th. Some of you can't multiply that in your head. I'm not sure I could very quick on the fly here. And so we will go for the root first. So 8 to the 1/3 power is another name for the cube root of 8, which most of you know is 2. Then the power is all you have left. 2 to the 5th, 2 times 2 times 2 times 2 times 2. 5 of them should be grand final answer of 32. So the y value for this one would have to be a 32. Again, you could check it, put it in, and take 32 to the negative 3/5 power if you're allowed to use a calculator. If not, put 32 in, take the 5th root of it, cube it, flip it, reciprocal, and you should get back to that 1/8 that we had originally. So I think that's good. Very similar to what we did when we spent 2 days on 7/7. Now we're just adding that third component of the reciprocal because of the negative exponent. I think you're on a roll. I think if you have any issues, questions, examples that you can't figure out, please bring those to class with you.